Dear students, today I am going to discuss on types of operating system. This is one of the important questions normally asked in the university exams. So let's see the different types. The first type of operating system is nothing but a batch operating systems. Now, as the name indicates, the batch is nothing but, let us take a particular job. This is a particular job you want to carry out, or a task. If this task you want to carry out, you can divide this task into small batch, and you allow first batch to process, then second batch to process, third batch to process. That is one after another in a serial manner. So this is called as a batch operating systems. Or let me put it in another way, is that suppose there are different job activities, say job 1, job 2, like that up to say job n. So these type of say first job is to process say Python. This job is to process say paintbrush. This job is to do a C++. So these type of activities, if the CPU has to performs, then CPU will do batch by batch. That is one after another. This particular type of processing is such that once any activities or any job is taken by CPU, it will never stop it in the middle. It will perform the complete, and then only it will go to the next. So this type of batch process, it has one deficiency with respect to the operating system. However, this is more or less like, we know that MS-DOS. In the MS-DOS, once the one instruction is run, it is when we run it, it will execute the entire activities before it takes or it goes for the next works. That is the first batch operating systems. Now the next batch operating system is nothing but, we put it as multi-programming. Now what multi-programming means? If a computer has a multiple processing, and or I can put it as if a computer can do a multiple activities by using programming methods, then that particular system is called as a multi-programming operating systems. So if you see the multi-programming operating systems today, most of the CPUs is based on the multi-programming, because many programming is runs under the CPU. At an instance, you can run MP3, you can run MP4, you can run MATLAB, you can run LaTeX, you can run Python. You can do multiple if multi-programming, if your processor is also capable. So normally you try to look for a high-end CPUs. And so this type of high-end CPU is nothing but a multiprocessor, that we'll see in the next. So if your CPU is high-end, it can able to process multiple programming. So whenever the operating systems can able to process more than one program, that is termed as a multi-programming. Now in this case, what is the advantage? The CPU is not idle. CPU is not idle, and here the CPU throughput means unit time processing. That means each CPU's processing time, it improves. So that is the multi-programming. You have a multiple program that CPU process. Now the next type of the operating systems, we termed it as a multitasking. What is multitasking? That means if your CPU it is similar to multi-programming. This is almost all similar to multi-programming, but in multitasking, the CPU process multiple task, that is more than one task. That as you use a paintbrush, use a word, you use MP3 word, paintbrush, everything the CPU will process at it, as per the time sharing modes, but it will carry out the multiple task and help the users. So that is known as multiple tasking. Now here also, if you try to see, the CPU utilizations improves. Now next is multi-processing. In the multi-processing, number of processing can be handled by CPU. See, CPU handle a number of processing. Number of processing means, say for example, you have a i3, i5, i7 CPU. So these are nothing but a multi-core. So multi-core multiprocessor is there. So more than one processor will work. Suppose you are having i5. Since it is having a multiple processor. So suppose one job is doing, let us take you are playing MP3, and this processor has got some problem. Immediately it will switch over to the next processor, or this processor it will switch over. So user will not know how the things, but you will be getting a constant output. That means your speaker will be working. That is what a multiprocessing is. Now after the multiprocessing, the next type of processing is called as a time sharing processing. Now what exactly the time sharing processing? So in the time sharing processing, I can put it as a fifth one. I put it as a fifth, time sharing. In the time sharing processing, the operating systems carry out in a time shared mode. Time shared mode means, say for example, you take an example is that you are allowing your one book. This is your one book, and your two friends want to read. You are having 5 friends, and they want to read this book. So what you do? You give this book to one friend for a certain time, then to the next friend same. So like that, you give it to the all 5 friends, 3, 4, 5. So this rendering or sharing this book for a certain time is known as a time sharing. In the same way, the CPU also carry out the individual task. So this is nothing but a task. So the task of a reading is being shared. So in the time sharing mode, we use a word TQ, that is a unit share. Or in another word, this TQ we call it as time quantum. That means CPU will only, suppose you are giving for say 3 minutes. So that means CPU will only permit for 3 minutes that task. After that it will go to the next task. Even if the task is not finished, it will interrupt and it will go to the next task. Or it will exit and it will go to the next task. So this is known as a time sharing mode. The next is nothing but the very important over which the operating systems nowadays being focused. It is nothing but RTOS, that is real time operating systems. In a real time operating systems is that it is that every activities is being carried out in a very scientific way, and based on real time. Real time means that whenever any activity has to do, suppose say for example, if gun want to fire at time t is equal to 5 minutes as per the clock. So that means that the RTOS, real-time operating system, will fire at t is equal to 5 minutes. It will neither exceed nor it will fire just before. So it will follow strictly the time, follow that particular time deadlines. So RTOS is basically used in a robotic applications, or you can space craft, launching, car driving. So these are today's many applications the RTOS is being used. And these RTOS are two types. One is hard RTOS and another is soft RTOS. Now, what is soft RTOS and hard RTOS? The difference is that here we cannot, once the time is set, you cannot change it. That means at a given time the activity will take place. But in soft RTOS is that there is a provision for change of time. So we normally says that in the hard RTOS, once the time is is set at a given time, that means say you want to give a car brake, automatic car braking systems as per the given event. If a particular event is that say some obstacle has come and if the car has to brake in that time, then in that particular situations we put it as a soft RTOS. And let us take a case that one process is running. After that the next process has to start. So this process will run for say 3 minutes. After that the next process has to run for 5 minutes. So after this process the next process has to start. This is known as a hard. That means in the hard RTOS, if it is set, you cannot change it, and in the soft RTOS you have a provision to change it in a different interval of times. And finally, lastly we have another point of operating system is nothing but a distributed operating systems. That is a distributed operating systems. In a distributed operating system is just like an internet. In the internet you are having a multiple servers. So here many servers are connected. So in distributor means data is located in a multiple distributions in a given network. So just like a satellite is a good example with respect to the operating system based on the distributor. So these different this is the seventh. These are the 7 different categories. One is batch operating systems, another is multi-programming, another third is multitasking, multiprocessing, time sharing, real-time operating system, and distributed operating systems. Thank you.